All right, good afternoon, everyone. My name's Zach Glick. I'll be your MC for this afternoon. I want to thank our sponsor, Beyond Trust. It's the worldwide leader in intelligent identity and access security, enabling organizations to protect identities, stop threats, and deliver dynamic access. They're leading the charge in innovating identity-first security, and are trusted by 20,000 customers, plus a global ecosystem of partners. I want to introduce Brad, who's going to talk about pipeline precognition. Welcome him to the stage.
Thank you so much, Zach. I appreciate that. Again, my name is Brad Geesaman. I'm a staff security engineer at Ghost Security. And today I'd like to talk about pipeline precognition, predicting attack paths before apply. And it stands to reason I would mess up with the alliteration on that title. I constantly ask myself why misconfigurations are still so common. I think about it all the time, and I struggle with it personally in my own organization. And one of the things that I tend to lean to is that there's some tooling and process help that we can do. I often am assigned reviewing PRs of infrastructure changes, and I'm the one that comes in and sort of tries to give a threat modeling spin on things and say, hey, that's going to do this or this, and I just can't scale. We have a small team, and I'm still not able to do what I'd like to do and give that feedback to the folks that are building infrastructure. And so I always think of like, how can I scale that process? How can I improve tooling in that regard? And so I look to basic workflows. You know, from a Terraform and CI pipeline workflow, the gray dotted line is the CI pipeline. We're proposing some changes. We're applying those changes if they look good from an infrastructure perspective, and then we're using the infrastructure, and the CI pipeline shuts down, and we move on our merry way. And later, maybe seconds, minutes, hours, days, weeks, or never, security review comes around and looks at things and says, hey, that is not ideal. We should probably go ahead and change that. There's some downsides to this, right? There's a slow feedback loop. And it's the highest cost of change. Once something's in production, it's got inertia. It's going to stay there, and it's going to take a lot more risk to the risk of the business to overcome that, to be able to say, hey, let's actually make that role lower privilege, for example. But the benefit of that is it's assessing the full picture in the environment. It can see everything. It can look at everything all together, right? So a couple years ago, maybe 3, 4, 5, 6 years ago, we started the shift left movement. We're trying to insert a little bit more security review inside that pipeline. So we're saying, hey, I'm going to propose some changes. Let's look at that. What do we do? What can we understand from that? And then before we go ahead and apply it, we have some level of confidence that some of the changes that we're making are not making silly mistakes, right? So it's a better feedback loop. Right? The PR doesn't merge, it doesn't get approved unless it passes some sort of standard check. So that's starting the muscle memory of that pattern, right? And it's the lowest point of the cost of the change because it hasn't been applied yet. And it actually is able to review partial and the full picture. I'll explain why that bothers me, right? Why do we still have 2 review steps? Why do we still need them? Generally speaking, and I can't speak for every tool vendor out there and every implementation, but generally speaking, the security review that's done between a plan and apply is somehow limited in scope. It's either limited to the repo, it's just looking at the Terraform that it's doing the change, just the plan. But if you look in reality, often there's some infrastructure that's already deployed that is not managed by this change. They work together in reality. So you're looking at resource-based misconfigurations, like this bucket has this ACL, not everything in a larger picture. But once it's in place, once it's in the environment, then we can do the full gamut. We can look at and do things like attack path modeling, which we'll get into in a bit. So you have sort of this hybrid setup where we're doing a little bit of light pass checking, compliance checking, yep, CIS benchmark, good to go. And then when it gets in, we're still surprised that there's risk, that there's attack paths that are opened up by accident, well-meaning attack paths, I call them. So I introduced the term attack path. I should explain what a resource misconfiguration is versus an attack path. A resource misconfiguration is a specific resources configuration. Maybe it's attribute, right? Think of just in that scope, did I set that to true, set that to false? And I like to think of an attack path as a configuration of multiple related resources that opens up a path to compromise or access to sensitive data or credentials. And it's typically a story. It's almost like a vignette of what an attacker could do. And it tends to be multiple combined misconfigurations across related resources. And that's the only way you can deduce what's happening. And I know there's a lot of vendors that do this and they do it very well. And that's a great thing. But I like to look for load-bearing limitations. Why can't we do that in the pipeline? What are the things that are preventing us from being able to do this earlier? Wouldn't it be great if we had all the benefit of that insight without making the change up front? So to do this, we need a couple things that probably don't exist. You need an always current and easily queryable representation of all those cloud resource configurations and their relationships to each other. You need to be able to then model specific combinations of potentially malicious behavior from these configurations on top of that representation. And the point is that this is something that you would be able to describe and define that makes sense for your needs. It's not just a standard set of checklist items. And then for this system to be queryable from a what-if perspective, if I gave you a proposed set of changes, can you do some what-ifing for me and provide that feedback of what risks were added or removed? But nobody talks to a system like that. Nobody's going to speak some big, large blob of JSON. So we need to make it palatable for the existing workflow. That's where wrapping Terraform comes in. I'm making a change like I normally do in Terraform. I want that to be my intention of what the change is going to be. And I want you to figure it out and then interface with the system and tell me what's going on. So I don't have to learn anything, and I'm not adding any specific knowledge to the developer or the DevOps team in the pipeline. To me, that's sort of the ground truth that we need to be able to do. And Kaizen and Psychic are two open source projects that are public as of yesterday that I'm attempting to prove the concept on. And I want to preface this that they are a proof of concept. They do not cover all resources. They do not cover all attack paths. And I'll explain why I didn't go all 100% or go some large amount of coverage at the end. But fundamentally, Kaizen is a resource graph. It's always up to date, and it's sitting there with open-ended modeling so you can write attack path queries on top of the resource graph, which I'll show you in a bit. And it has an API that says, hey, give me a change set. I'll do a what-if analysis, and I'll send it back to you. And then Psychic is the tool that I like to call it. It looks in the future. So it's Psychic. It wraps Terraform and makes Terraform be easy to handle when you're trying to interface with Kaizen. So I'm a visual person. I like to think of pictures for systems with no words. So you could just see big blocks. Kaizen's the graph database. It's interfacing with, in this case, GCP. I wrote it for GCP. And it's just saying, keep me up to date. The cloud asset inventory is the majority source for all this information, right? But you need it queryable in a way that you can control and that you can make arbitrary relationships. And that's not something that's easily supported, or if it is, it's in a premium product. And what I mean by a resource graph, this is another term and definition, it's all of the resources in their interrelationships with some metadata attached to them. Okay, so we're thinking of the VM, the role, the permission, et cetera, and it's in the project. From that, though, from that same graph, we're talking about how do we write expressions that sort of simplify and human readable, make sense of that resource graph. It's just a lot, I promise you. Even the smallest amount of infrastructure blows up, right? How do you reason about that? And that's where the attack paths come in, and I'll show you better by example. But from a meta perspective, it's, I don't know if you can see the fade. Yeah, it's kind of faded. It's hopping between the relevant nodes, right? To describe something as internet accessible, you need a security group, you need a route, you need a VPC, you need 7 or 8 things in a chain to be true for you to draw up. Yep, just shortcut that. User on the internet can access this remotely, right? That people understand. They don't understand the resource graph. They understand this is an accessible workload, Okay, it has a credential. Okay, it can do bad things to the database if that were to be compromised. So Kaizen also has that API, so I'm sort of building up on that same architecture diagram there. It has an API to interface with it to ask it about change sets. So if I'm the human up there and I want to say, hey, what if I add a virtual machine and an IAM role that looks like this? Would I do some good things or some bad things? What that fundamentally means is if I'm going to change these resources configuration, send me back the attack paths that were added or removed, and with a score, so I can see, did I improve things or did I make things worse? But nobody wants to talk JSON to an API like that. That's just, again, a lot of JSON parsing, to be quite honest. That's where Scikit comes in. Scikit attempts to trick Terraform into talking to it. It's an intercepting proxy, and it fakes responses that the resource was applied. And the reason why it does that is so that it gets all the metadata with high fidelity. If you parse just a Terraform plan, you might not get all the variable names and the service account emails and the role names until they're created. So you might as well just be in line and watching what's going on between the Terraform provider and the cloud provider. Well, what's fun is if you just fake back, like I want to create a resource and you go, yep, it's created, and you give it the right shape, Terraform's happy. But you got all of that change set. So if you intercept all of the calls to create, post, patch, or delete, you understand what the change is. And then you can take that and say, okay, Terraform, be quiet for a minute, and we'll throw it against the graph. We'll start a transaction. We'll run an attack path simulation. We'll apply changes to the graph per that change set. We'll rerun the attack path modeling and go, which ones were created and which ones were not. And we'll just abort the transaction and throw it away. Live demo time. All right. So first thing I want to show you is what a resource graph looks like in a pretty small environment. I have an internet accessible Cloud Run, which is a container running service, right? So it's just running an API. And it has access to a database. And it has also a service account that lets it talk to Cloud SQL, right? So it's just a basic standard web app. But this revision of Cloud Run is running an image of 1.1.1, and it has two vulnerabilities. And this is where it starts to get interesting. And this is also where your graph explodes, by the way, because if you have thousands of CVEs, you have a relationship for every single one. But interestingly enough, also in this registry, there's a 1.1.2 that has one fewer. So we'll get to that. And if those of you who are sharp-eyed, eagle-eyed, and I'm going to zoom in. Let's go here. Anybody pick up on this? There is also in this project, just sitting over here, a cloud build service account that is granted org administrator. That'll be important in a minute, right? It's kind of sitting off to the side. It's just there. It's doing no harm yet. So if I want to, apologize. But that's a lot, right? What if I wanted to show you in story form and visual form something a little bit more palatable? What we have here, and forgive the auto physics, I have to adjust it every time. We have that big resource graph. If we run a couple queries, we can make synthetic links between some of the core nodes, and we can start talking in MITRE attack paths. So we could say anonymous user has two initial access vectors, two CVE loans to this publicly exposed Cloud Run. And the impact is resource hijacking, crypto mining, right? That could be the end of an attack path, and I'll show you in a second it is one. But it interestingly also has credential access to a service account. Everybody has an attached service account to a workload. That's not a big deal, but that has data destruction for impact, or data encryption for impact, and data destruction to the database, right? All of a sudden it's starting to tell a story. If this is compromised, they can get to the data, they can destroy it, they can change it, they can exfiltrate it. I didn't want to put every single possible attack path in here. I'm trying to do this for a show of examples, but you could have any number of impact links to this. What you ultimately get are individual traversals of the graph with a likelihood, a threat, and an impact score. A risk score. So this is 1200 is the worst. So right now, just sitting still, we have a score of 1200. So I'm over here as a DevOps engineer, and I'm going to do something I shouldn't, but I don't know that I shouldn't, is I'm going to allow that Cloud Run to also have a binding to editor and project editor. Now, those of you who know anything about GCP, that's probably not a good idea, but we're doing it for effect. Okay, so I just want to show you what a Terraform plan would look like. This tends to be sort of the scope of what you're reviewing when you're looking at a CI change. You're like, oh, they're just adding editor. Well, it depends. Are there things in the environment in that project? Maybe there aren't any today, but in the future there are. That makes this a bad idea. So enter Psychic. It's going to go kind of quickly, and I'm going to scroll past it because it happens in a few seconds, and I'll talk through what's going on. But basically, it's starting an MITM proxy, and it's running a Terraform apply and pointing Terraform to it, faking responses, capturing the change set, and then running, sorry, I need to run this again. Cell phone reception. Here we go. Takes a few seconds. There we go. Fundamentally, we took that change set, we threw it to Kaizen and said, hey, what if? Send me back the results. And then I'm just spitting it out here in JSON. Forgive the lack of a TUI or a CLI UI. But you see that 1283, right? Do you remember that? That's the current attack paths that are present. But if that change were applied, we would have a 70,000. So, we went to 1200, 70,000, and a 15,000. Well, what happened? I did my best to shorten the output of this, but you could see that there's one more hop there that allows administrator access to the control plane at the org level. I realize looking at a bunch of JSON, you're like, oh, okay. All right, so let's do a quick visual as if I had applied that, okay? So I'm gonna hit run on this. That's patching the editor change to the graph for real. And then I'm gonna rerun one of the extra attack paths queries. And then I'm gonna go back here and we're gonna rerun this story. We're gonna repaint this picture and say, now do you see this extra impact here? And the reason why this happened is because project editor has IAM service account act as plus another permission to run a workload, which is like saying pass role and then create EC2 instance. And if you can do that, any other service account in the project is up for grabs being attached to that workload. And whatever its permissions are, you have as well. So there's an escalation attack path up to org administrator. So this is a bad day. This is where you see the 70,000. Okay? So what if I just forgot that happened? How do I prove that I reduced some risk? So down here in this Terraform that controls this Cloud Run, remember I talked about that 1.1.1 that had 2 vulns? What if I patched the worst vuln, the highest risk score? And that's in 1.1.2, we'll say. So if I Terraform plan it again, you can see the change is about to be made. We're just going to change the image, okay? So if I run Psychic again, we have removed the 70,000 score path because we took off this link right here. Okay, so we removed that vulnerability, removed that attack, that started that attack path. So in this POC, and I stress it's a POC, we're able to do full attack path analysis of risks added or removed before we were doing a Terraform apply. And notice I didn't make any Terraform applies in there, did I? I didn't change anything in the real world. And we mapped those steps to MITRE attack path TCPs, And we built ourselves a real-time, high-fidelity representation of resource state so that we can support any kind of what-if analysis. Again, this is a demo, and I will stress, if you look at that source code, you're going to just be prepared. And the proxy intercept code that I wrote is extremely brittle and not scalable to write. So here's my wish list, and this is my last slide. I want this asset inventory to be a first-class citizen. I want CSPs to build this functionality. I don't want to run this or manage this. And for that to happen, we need to have some sort of a dry run capability. I would love it to be able to say, changes I'm about to apply, don't actually apply them, to be able to support this type of workflow. And that way we can have resource-based and context-based, risk-based prioritization using this graph. So if we can always query this, we can look at the state of the system at any point in time and understand what those risks are. And I just want to say thank you to MITRE and Lyft for the inspiration, and here's the source code, and I hope that this was inspiring to you to think in the forward-looking sense of like, what if we had this? What would we be able to do? How would we be able to change the status quo? Thank you.
You got a little bit soccer questions?
Okay.
So Terraform was a pretty obvious choice for working on this. Do you see any path towards transiting this to be able to sit in front of API calls directly to the cloud providers, or something like Pulumi or anything else?
Yeah, I use HTTPS proxy and HTTP proxy to tell Terraform to point to MITM proxy. So in theory, if any of the CLI tools were to honor that, it would intercept it just the same. That's basically what it looks like when it comes across the wire from the Terraform provider. It just looks like posts and patches and gets and deletes. So in theory, you could point anything to the proxy and it would intercept it and see it the same.
Awesome, thanks.
Awesome work, by the way. Your container initial compromises, vulnerabilities, CVEs, where in the data set you're pulling from the cloud provider are they coming from? Is that like a Google service that you've enabled and are pulling that feed, or is that separate?
Yeah, so this is, there's actually two sets of projects. I won't get into the sort of the nitty gritty. There's this side work that I've done that's working with artifact registry and container analysis, scanning pub subs and just watching those and populating the graphs. So if you scan your container and you log it in artifact registry scanning, you'll get a message with all the CVEs. So you can just throw that in the graph real time.
Hi, you mentioned that the proxy was pretty brittle, and I imagine that you probably looked into other man-in-the-middle proxies that previously existed and you found that they didn't work for your use case. What was the limitation there, if there was any?
I looked as far as I got it working. So if there are better proxies out there, I would. If anybody finds this interesting, like this is just the start of it. It's like to prove the value. I was using MITM dump with the Python add-on, and I was just.
I work as a pen tester, and a lot of proxies that we sometimes use are things like Burp Suite, but I don't know how brittle Burp Suite is for something like this. So.
Let me be clear, the code that is brittle is mine. They do just fine. They'll send you the request reliably as ever. It's just how do I handle it? There's a lot of entropy in a lot of the fields, so you just have to account for a lot of the use cases, and that's why I say it's not so scalable, but it proves the concept.
We got time for one more question.
It wants you.
It wants you.
There.
Thank you very much for talk. Just a quick one around using Cypher or memgraph as you were. One of the challenges I found with it was being able to store complex objects and then having nested JSON and all that cool stuff, which is quite common with cloud resources.
Yep.
How have you handled that limitation? How have you worked around that?
So Redis Graph only stores KVs. Memgraph and Neo support nested objects. So I can show this right here is a JSON blob of the CVE details.
Okay.
So that's how I get around it.
Cool.
It just takes it.
All right, let's give our speaker a big round of applause.